Observability and SRE Part 5. This episode has 22 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Kafka troubleshooting. How would you troubleshoot Kafka producer, broker, consumer lag, and consumer group issues? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 2. PostgreSQL HA or backup. How would you design and troubleshoot PostgreSQL high availability and backup or restore? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 3. CI or CD. How would you troubleshoot GitHub Actions or CI or CD pipeline failures in production delivery? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 4. Observability. What Grafana and Prometheus dashboards would you build for production support? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 5. Terraform. How do you manage Terraform state, modules, locking, drift, and safe production changes? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 6. GCP services. Explain how you have used GKE, IAM, VPC, Cloud SQL, and Load Balancer in production. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good. Here's another one. Question 7. Linux troubleshooting. How do you troubleshoot Linux CPU, memory, disk, network, and process issues during an incident? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 8. Incident handling. How do you handle production incidents and write an RCA? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Great. Moving on. Question 9. System design. Design scalable cloud infrastructure for a production application on GCP. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Alright, next question. Question 10. Behavioral or leadership. Describe a time when a production system you were responsible for degraded or failed. What happened? How did you detect it? What immediate actions did you take? And how did you prevent recurrence? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Let's keep going. Question 11. Behavioral or leadership. Give an example of infrastructure you architected or significantly improved. Cloud, IaaC, containerized stack. What trade-offs did you weigh? Cost, scalability, resilience, maintenance, and what would you do differently now? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. On to the next one. Question 12. Behavioral or leadership. Describe a situation where you had to create or improve monitoring, observability, or alerting for a system. What metrics or logs or traces did you choose? How did you set alert thresholds or slows? And how did you measure success? We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Good. Here's another one. Question 13. Behavioral or leadership incomplete in source. Question was cut off after. Have you ever had to write automation or capture the rest next time this screenshot or page is available? Then replace this entry. We don't have a model answer recorded for that one yet, so it's a good one to research on your own. Nice. Let's continue. Question 14. Python automation. How would you build a Python tool that audits GCP projects for IAM risk, public buckets, unused firewall rules, missing labels, and cost anomalies? Here's a strong way to approach it. Use the resource manager, IAM, storage, and compute client libraries to enumerate projects and pull IAM bindings, flagging broad roles like owner on non-human accounts, bucket IAM policies, flagging all users or all authenticated users, Firewall rules unused in recent flow logs, and resources missing required labels. Combine this with a billing export query for week-over-week cost spikes. Score findings by severity, and output a report or feed them into a ticketing system rather than auto-remediating blindly. Great. Moving on. Question 15. Cloud security. How would you secure workload access to GCP services from GKE using workload identity, IAM, secret manager, and least privilege? Here's a strong way to approach it. Bind each Kubernetes service account to a dedicated GCP service account via workload identity so pods get short-lived, automatically rotated credentials instead of mounted JSON keys, and grant that GCP service account only the specific IAM roles the workload needs, not project-level editor. Pull secrets at runtime from secret manager via the workload identity-bound identity rather than baking them into images or Kubernetes secrets, and review bindings periodically to remove unused permissions. Alright, next question. Question 16. Vertex AI and MLOps. A team wants model serving on Kubernetes with fast API and GPU workloads. How would you design deployment, autoscaling, monitoring, and rollback? Here's a strong way to approach it. Package the model behind a fast API service in a container with GPU driver compatibility. Deploy on a GPU node pool with taints or tolerations so only ML workloads schedule there, and autoscale using a custom metric, queue depth or GPU utilization rather than plain CPU since GPU-bound inference doesn't correlate well with CPU usage. Monitor latency, throughput, and GPU utilization, and roll out changes via Canary with automatic rollback if error rate or latency regresses beyond a threshold. Let's keep going. Question 17. Go optional. Where would Go be useful in a platform engineering environment, and how would you decide between Go, Python, and Bash for automation? Here's a strong way to approach it. Go is the right choice for building Kubernetes controllers or operators. Keys distributed to many engineers, single static binary, fast startup, and any tool needing high concurrency or low resource overhead as a long-running service. Python is better for scripts with heavy API or data manipulation and faster iteration where startup time doesn't matter. Bash is fine for short glue scripts and simple orchestration but should be rewritten in Python or Go once it grows past a few dozen lines of real logic. On to the next one. Question 18. Terraform state. A Terraform apply failed halfway and no remote state does not match real GCP resources. How would you recover safely in an enterprise environment? Here's a strong way to approach it. First run Terraform plan to see the actual drift between state and reality without applying anything, and use Terraform state list or show to identify exactly which resources are inconsistent. Use Terraform import to bring resources that were created but not recorded in state back under management, or Terraform state RM for resources that need to be recreated. And always take a state backup before any manual state surgery so you can revert if the recovery makes things worse. Good. Here's another one. Question 19. Cloud Run versus GKE. A company wants to standardize Cloud Run and GKE usage. How would you decide which workloads go to Cloud Run versus GKE? Here's a strong way to approach it. Cloud Run fits stateless, request-driven services with variable or bursty traffic that benefit from scale to zero and minimal operational overhead. GKE is the right choice for workloads needing fine-grained control, custom networking, sidecars, stateful sets, GPU scheduling, service mesh, or complex multi-container pods, and for teams that need Kubernetes native tooling across many services. A simple heuristic: default new stateless services to Cloud Run, and only justify GKE when a specific requirement Cloud Run can't meet is identified. Nice. Let's continue. Question 20. Cloud SQL or AlloyDB. How would you troubleshoot a private GKE workload that cannot connect to Cloud SQL or AlloyDB? Here's a strong way to approach it. Check whether the connection uses the Cloud SQL auth proxy or sidecar or direct private service access, and verify private Google access and the VPC peering range are correctly configured if using private IP. Confirm firewall rules allow the GKE pod CIDR to reach the database port. Check the Cloud SQL instance's authorized networks or private service connect config, and verify the service account has the Cloud SQL client IAM role. A very common cause is the pod's workload identity binding missing that role. Great. Moving on. Question 21. Pub or sub reliability. A pub or sub consumer service is falling behind and message AGI is increasing. How would you debug backlog, scaling, ordering, retries, and dead letter handling? Here's a strong way to approach it. Check the subscription's oldest unacted message AGI and undelivered message count in cloud monitoring to confirm backlog growth. Then check whether the consumer is CPU or I/O bound, needs more replicas or concurrency, or blocked on a slow downstream dependency. Review the ACT deadline versus actual processing time. Too short causes redundant redelivery. Verify ordering keys aren't serializing throughput unnecessarily. And confirm a dead letter topic is configured so poison messages don't block the subscription indefinitely. Alright, next question. Question 22. Cloud storage security. How would you design cloud storage bucket security for logs, artifacts, and data exports, including IAM, retention, lifecycle, CMEK, and public access prevention? Here's a strong way to approach it. Enable public access prevention at the org policy level so buckets can never be made public even by mistake. Use uniform bucket level IAM, not legacy ACLs, scoped to specific service accounts or groups per bucket purpose. And apply retention policies or object lock for compliance-sensitive logs so they can't be deleted early. Use CMEK for sensitive data exports where you need key rotation control. And configure lifecycle rules to transition or delete objects automatically based on age to control cost. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.